Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Blockchain. A blockchain, originally blockchain, is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data generally represented as a Merkle tree. By design, a blockchain is resistant to modification of the data. It is an open, distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. For use as a distributed ledger, a blockchain is typically managed by a peer-to-peer network, collectively adhering to a protocol for inter-node communication and validating new blocks. Once recorded, the data in any given block cannot be altered retroactively without alteration of all subsequent blocks, which requires consensus of the network majority. Although blockchain records are not unalterable, blockchains may be considered secure by design and exemplify a distributed computing system with high Byzantine fault tolerance. Decentralized consensus has therefore been claimed with a blockchain. Blockchain was invented by a person or a group of people using the name Satoshi Nakamoto in 2008 to serve as the public transaction ledger of the cryptocurrency Bitcoin. The identity of Satoshi Nakamoto remains unknown to date. The invention of the blockchain for Bitcoin made it the first digital currency to solve the double spending problem without the need of a trusted authority or central server. The Bitcoin design has inspired other applications, and blockchains that are readable by the public are widely used by cryptocurrencies. Blockchain is considered a type of payment rail. Private blockchains have been proposed for business use. Computer World called the marketing of such blockchains without a proper security model snake oil. History. Cryptographer David Chaum first proposed a blockchain-like protocol in his 1982 dissertation, Computer Systems Established, Maintained, and Trusted by Mutually Suspicious Groups. Further work on a cryptographically secured chain of blocks was described in 1991 by Stuart Haber and W. Scott Stornetta. They wanted to implement a system where document timestamps could not be tampered with. In 1992, Haber, Stornetta, and Dave Bayer incorporated Merkle trees to the design, which improved its efficiency by allowing several document certificates to be collected into one block. The first blockchain was conceptualized by a person or group of people known as Satoshi Nakamoto in 2008. Nakamoto improved the design in an important way using a hash cache-like method to timestamp blocks without requiring them to be signed by a trusted party, and introducing a difficulty parameter to stabilize rate with which blocks are added to the chain. The design was implemented the following year by Nakamoto as a core component of the cryptocurrency Bitcoin, where it serves as the public ledger for all transactions on the network. In August 2014, the Bitcoin blockchain file size containing records of all transactions that have occurred on the network reached 20 gigabytes. In January 2015, the size had grown to almost 30 gigabytes. And from January 2016 to January 2017, the Bitcoin blockchain grew to more than 50 gigabytes to 100 gigabytes in size. The ledger size had exceeded 200 gigabytes by early 2020. The words block and chain were used separately in Satoshi Nakamoto's original paper, but were eventually popularized as a single word, blockchain, by 2016. According to Accenture, an application of the diffusion of innovations theory suggests that blockchains attained a 13.5% adoption rate within financial services in 2016, therefore reaching the early adopters phase. Industry trade groups joined to create the Global Blockchain Forum in 2016, an initiative of the Chamber of Digital Commerce. In May 2018, Gartner found that only 1% of CIOs indicated any kind of blockchain adoption within their organizations, and only 8% of CIOs were in the short term planning or looking at active experimentation with blockchain. Structure. A blockchain is a decentralized, distributed, and oftentimes public digital ledger, consisting of records called blocks, that is used to record transactions across many computers, so that any involved block cannot be altered retroactively without the alteration of all subsequent blocks. This allows the participants to verify and audit transactions independently and relatively inexpensively. A blockchain database is managed autonomously using a peer-to-peer network and a distributed time-stamping server. They are authenticated by mass calibration powered by collective self-interests. Such a design facilitates robust workflow where participants' uncertainty regarding data security is marginal. The use of a blockchain removes the characteristic of infinite reproducibility from a digital asset. It confirms that each unit of value was transferred only once, solving the long-standing problem of double spending. A blockchain has been described as a value exchange protocol. A blockchain can maintain title rights because, when properly set up to detail the exchange agreement, it provides a record that compels offer and acceptance. Blocks. Blocks hold batches of valid transactions that are hashed and encoded into a Merkle tree. Each block includes a cryptographic hash of the prior block in the blockchain, linking the two. The linked blocks form a chain. This iterative process confirms the integrity of the previous block, all the way back to the original Genesis block. Sometimes separate blocks can be produced concurrently, creating a temporary fork. In addition to a secure hash-based history, any blockchain has a specified algorithm for scoring different versions of the history, so that one with a higher score can be selected over others. Blocks not selected for inclusion in the chain are called orphan blocks. Peers supporting the database have different versions of the history from time to time. They keep only the highest scoring version of the database known to them. Whenever a peer receives a higher scoring version, usually the old version with a single new block added, they extend or overwrite their own database and retransmit the improvement to their peers. This is never an absolute guarantee that any particular entry will remain in the best version of the history forever. Blockchains are typically built to add the score of new blocks onto old blocks, and are given incentives to extend with new blocks rather than overwrite old blocks. Therefore, the probability of an entry becoming superseded decreases exponentially as more blocks are built on top of it, eventually becoming very low. For example, Bitcoin uses a proof-of-work system where the chain with the most cumulative proof of work is considered the valid one by the network. There are a number of methods that can be used to demonstrate a sufficient level of computation. Within a blockchain, the computation is carried out redundantly rather than in the traditional, segregated, and parallel manner. Block time. The block time is the average time it takes for the network to generate one extra block in the blockchain. Some blockchains create a new block as frequently as every 5 seconds. By the time of block completion, the included data becomes verifiable. In cryptocurrency, this is practically when the transaction takes place. So a shorter block time means faster transactions. The block time for Ethereum is set to between 14 and 15 seconds, while for Bitcoin it is on average 10 minutes. Hard forks. A hard fork is a rule change such that the software validating according to the old rules will see the blocks produced according to the new rules as invalid. In case of a hard fork, all nodes meant to work in accordance with the new rules need to upgrade their software. If one group of nodes continues to use the old software while the other nodes use the new software, a permanent split can occur. For example, Ethereum has hard forked to make whole the investors in the DAO, which have been hacked by exploiting a vulnerability in its code. In this case, the fork resulted in a split creating Ethereum and Ethereum Classic chains. In 2014, the Next community was asked to consider a hard fork that would have led to a rollback of the blockchain records to mitigate the effects of a theft of 50 million Next from a major cryptocurrency exchange. The hard fork proposal was rejected, and some of the funds were recovered after negotiations and ransom payment. Alternatively, to prevent a permanent split, a majority of nodes using the new software may return to the old rules, as was the case of Bitcoin split on 12th of March 2013. Decentralization. By storing data across its peer-to-peer network, the blockchain eliminates a number of risks that come with data being held centrally. The decentralized blockchain may use ad hoc message passing and distributed networking. Peer-to-peer blockchain networks lack centralized points of vulnerability that computer crackers can exploit. Likewise, it has no central point of failure. Blockchain security methods include the use of public key cryptography. A public key, a long random-looking string of numbers, is an address on the blockchain. Value tokens sent across the network are recorded as belonging to that address. A private key is like a password that gives its owner access to their digital assets or the means to otherwise interact with the various capabilities that blockchains now support. Data stored on the blockchain is generally considered incorruptible. Every node in a decentralized system has a copy of the blockchain. Data quality is maintained by massive database replication and computational trust. No centralized official copy exists, and no user is trusted more than any other. Transactions are broadcast to the network using software. Messages are delivered on a best effort basis. Mining nodes validate transactions, add them to the block they are building, and then broadcast the completed block to other nodes. Blockchains use various time-stamping schemes such as proof of work to sterilize changes. Alternative consensus methods include proof of stake. Growth of decentralized blockchain is accompanied by the risk of centralization because the computer resources required to process larger amounts of data become more expensive. Openness. Open blockchains are more user-friendly than some traditional ownership records, which, while open to the public, still require physical access to view. Because all early blockchains were permissionless, controversy has arisen over the blockchain definition. An issue in this ongoing debate is whether a private system with verifiers tasked and authorized, permissioned, by a central authority should be considered a blockchain. Proponents of permissioned or private chains argue that the term blockchain may be applied to any data structure that batches data into time-stamped blocks. These blockchains serve as a distributed version of multi-version concurrency control, MVCC, in databases. Just as MVCC prevents two transactions from concurrently modifying a single object in a database, blockchains prevent two transactions from spending the same single output in a blockchain. Opponents say that permissioned systems resemble traditional corporate databases, not supporting decentralized data verification, and that such systems are not hardened against operator tampering and revision. Nikolai Hampton of Computer World said that many in-house blockchain solutions will be nothing more than cumbersome databases, and without a clear security model, proprietary blockchains should be eyed with suspicion. Permissionless. The great advantage to an open, permissionless, or public blockchain network is that guarding against bad actors is not required and no access control is needed. This means that applications can be added to the network without the approval or trust of others, using the blockchain as a transport layer. Bitcoin and other cryptocurrencies currently secure their blockchain by requiring new entries to include a proof of work. To prolong the blockchain, Bitcoin uses hashcash puzzles. While Hashcash was designed in 1997 by Adam Back, the original idea was first proposed by Cynthia Dwork and Moni Nayar and Eli Poniatowski in their 1992 paper, Pricing via Processing or Combating Junk Mail. In 2016, venture capital investment for blockchain-related projects was weakening in the USA but increasing in China. Bitcoin and many other cryptocurrencies use open public blockchains. As of April 2018, Bitcoin has the highest market capitalization. Permissioned private blockchain. Permissioned blockchains use an access control layer to govern who has access to the network. In contrast to public blockchain networks, validators on private blockchain networks are vetted by the network owner. They do not rely on anonymous nodes to validate transactions, nor do they benefit from the network effect. Permissioned blockchains can also go by the name of consortium blockchains. Disadvantages of private blockchain. Nikolai Hampton pointed out in Computer World that there is also no need for a 51% attack on a private blockchain, as the private blockchain most likely already controls 100% of all blocks creation resources. As the private blockchain most likely already controls 100% of all block creation resources. If you could attack or damage the blockchain creation tools on a private corporate server, you could effectively control 100% of their network and alter transactions however you wished. This has a set of particularly profound adverse implications during a financial crisis or debt crisis, like the financial crisis of 2007-08, where politically powerful actors may make decisions that favor some groups at the expense of others, and the Bitcoin blockchain is protected by the massive group mining effort. It's unlikely that any private blockchain will try to protect records using gigawatts of computing power. It's time-consuming and expensive. He also said, within a private blockchain, there is also no race. There's no incentive to use more power or discover blocks faster than competitors. This means that many in-house blockchain solutions will be nothing more than cumbersome databases. Blockchain analysis. The analysis of public blockchains has become increasingly important with the popularity of Bitcoin, Ethereum, Litecoin, and other cryptocurrencies. A blockchain, if it is public, provides anyone who wants access to observe and analyze the chain data, given one has the know-how. The process of understanding and accessing the flow of crypto has been an issue for many cryptocurrencies, crypto exchanges, and banks. The reason for this is accusations of blockchain-enabled cryptocurrencies enabling illicit dark market trade of drugs, weapons, money laundering, etc. A common belief has been that cryptocurrency is private and untraceable, thus leading many actors to use it for illegal purposes. This is changing, and now specialized tech companies provide blockchain tracking services, making crypto exchanges, law enforcement, and banks more aware of what is happening with crypto funds and fiat crypto exchanges. The development, some argue, has led criminals to prioritize use of new cryptos such as Monero. The question is about public accessibility of blockchain data and the personal privacy of the very same data. It is a key debate in cryptocurrency and ultimately in blockchain. Uses. Blockchain technology can be integrated into multiple areas. The primary use of blockchains today is as a distributed ledger for cryptocurrencies, most notably Bitcoin. There are a few operational products maturing from proof of concept by late 2016. Businesses have been thus far reluctant to place blockchain at the core of the business structure. Cryptocurrencies. Most cryptocurrencies use blockchain technology to record transactions. For example, the Bitcoin network and Ethereum network are both based on blockchain. On 8th of May 2018, Facebook confirmed that it would open a new blockchain group, which would be headed by David Marcus, who previously was in charge of Messenger. Facebook's planned cryptocurrency platform Libra was formally announced on June 18, 2019. Smart contracts. Blockchain-based smart contracts are proposed contracts that can be partially or fully executed or enforced without human interaction. One of the main objectives of a smart contract is automated escrow. An IMF staff discussion reported that smart contracts based on blockchain technology might reduce moral hazards and optimize the use of contracts in general. But no viable smart contract systems have yet emerged. Due to the lack of widespread use, their legal status is unclear. Financial services. Major portions of the financial industry are implementing distributed ledgers for use in banking, and according to a September 2016 IBM study, this is occurring faster than expected. Banks are interested in this technology because it has potential to speed up back-office settlement systems. Banks such as UBS are opening new research labs dedicated to blockchain technology in order to explore how blockchain can be used in financial services to increase efficiency and reduce costs. Berenberg, a German bank, believes that blockchain is an overhyped technology that has had a large number of proofs of concept, but still has major challenges and very few success stories. In December 2018, Bitwala launched Europe's first regulated blockchain banking solution that enables users to manage both their Bitcoin and Euro deposits in one place, with the safety and convenience of a German bank account. The bank account is hosted by the Berlin-based Solaris Bank. The blockchain has also given rise to initial coin offerings, ICOs, as well as a new category of digital asset called security token offerings, STOs. Also sometimes referred to as digital security offerings, DSOs. STO DSOs may be conducted privately or on a public regulated stock exchange and are used to tokenize traditional assets such as company shares, as well as more innovative ones like intellectual property, real estate, art, or individual products. A number of companies are active in this space, providing services for compliant tokenization, private STOs, and public STOs. Video games. A blockchain game, CryptoKitties, launched in November 2017. The game made headlines in December 2017 when a CryptoKitty character, an in-game virtual pet, was sold for more than $100,000 US. CryptoKitties illustrated scalability problems for games on Ethereum when it created a significant congestion on the Ethereum network, with about 30% of all Ethereum transactions being for the game. CryptoKitties illustrated scalability problems for games on Ethereum when it created significant congestion on the Ethereum network, with about 30% of all Ethereum transactions being for the game. CryptoKitties also demonstrated how blockchains can be used to catalog game assets. Energy trading. Blockchain is also being used in peer-to-peer energy trading. Supply chain. There are a number of efforts and industry organizations working to employ blockchains in supply chain management. Mining. Blockchain technology allows wholesalers, retailers, and customers to track the origin of gems, stones, and other precious commodities. In 2016, the Wall Street Journal reported that the blockchain technology company Everledger was partnering with IBM's blockchain-based tracking service to trace the origin of diamonds to ensure that they were ethically mined. Food supply. Blockchain technology is being used to allow consumers to track the provenance of beef and other food products from their origins to stores and restaurants. Walmart and IBM are running a trial to use a blockchain-backed system for supply chain monitoring for lettuce and spinach. All nodes of the blockchain are administered by Walmart and are located on the IBM cloud. One cited benefit is that the system will enable rapid tracing of contaminated products. Fogo de Chão announced a partnership with HerdX that will allow the company's blockchain-based technology that will enable suppliers, wholesalers, and diners to trace the origins of beef served in their restaurants. Blockchain software development. The Linux Foundation's blockchain initiative, Hyperledger Grid, develops open components for blockchain supply chain solutions. The goal of the project, said the Foundation, was to accelerate the development of blockchain-based solutions to cross-industry supply chain problems. Domain names. Blockchain domain names are another use of blockchain on the rise. Unlike regular domain names, blockchain domain names are entirely an asset of the domain owner and can only be controlled by the owner through a private key. The blockchain domains pave way to have sites that are more resistant to censorship and thus enabling freedom of speech, as there are no authorities or individuals that can intervene on controlling a domain except the private key holder. Again, they are a better option to replace the traditional cryptocurrency wallet addresses, as one can easily memorize the domain and use it for receiving payments. Organizations providing blockchain domain name services include Unstoppable Domains, Namecoin, and Ethereum Name Services.